on
For a
computer.
while. Window. Is my screen already visible, ma'am?
We see. Okay, see.
Okay. Thank you so much for the feedback. Again, good day, everyone. I am Jennifer Villar Oranyo from Southern Leyte State University, Philippines. And on behalf of my co-authors, I have the honor to present to you our paper entitled Integrating Deep Learning and GIS for Herbal Plant Identification and a Location Finding System. So my presentation is outlined according to this sequence: introduction, the problem statement, the methodology, the results and discussion, and lastly is the conclusion. So for the rationale, herbal plants, it holds a significant and unique position as natural remedies for human health. Among these medical plants, um, it is integral to the traditional healthcare system worldwide. And for millions, particularly living in remote areas or rural areas such as Southern Leyte, traditional medicine continues to be the preferred choice for our health and wellness, and in delivering care that is culturally appropriate, accessible, and also affordable. Thus, it is essential to document these plants and the traditional knowledge of these plants for public health and drug development. Due to the vast number of medicinal plants, classifying them is a complex and time consuming task, even for seasoned botanists, as it largely depends on the specialized knowledge being transferred down or passed down to by the experts. And although many people are aware of the existence of these herbal plants and their common applications, they often struggle to identify these plants within the diverse plant life around us, as well as in recognizing and approve usage of these herbal plants according to the professionals. And in our province, it is evident that younger generations have recently struggled to recognize. Even I have struggled in recognizing herbal plants and have limited understanding of the traditional application of these herbal remedies. And additionally, finding the precise sites where these herbal plants grow is difficult and also time consuming if we don't know the location where we can find these herbal plants around the area. These challenges concerning the identification and the familiarization with the herbal plants as well as locating them within the area necessitates the need to develop a system for recognizing and locating these plants. Thus, this study circles around integrating deep learning and GIS for identifying herbal plants and also in locating these herbs within the area. For the methodology, um, for the conceptual framework of, excuse me, for the conceptual framework of the study, um, we have utilized captured leaves of these herbal plants to be the training and testing data. For the training data, we use this leaf for the generation of the CNN model. And also, this data, by the way, is captured on the ground, meaning it is originally captured using mobile phones and digital cameras. And as well as, so once we gather also the images, we also gather the coordinates as well, where we have find this um, herbal plants around the area. And with this data that we have, the images will be utilized for the generation of the CNN model, while the coordinates will be utilized later on for mapping out where these plants can be found within the area. And thus, we have here the application is will be outputting herbal plant local name, the corresponding scientific name, and also it will be displaying the uses of this herbal plant, and you can find as well the location of these herbal plants around the area. And this is showing you the example of some sample images that we have captured for each of the herbal plants that we utilize for the training. So all in all, we have 10 types of herbal plants, and we have utilized local names because we wanted also to promote it to especially to younger generations, the local names of these herbal plants. And on the left side, you can see the sample coordinates that we have gathered also during the data gathering. And this is the distribution of the data per phases. Like for the training, we have 80 samples per class, validation 10 samples per class, and for the testing, we have 50 sample that includes already during the deployment of the model in the mobile phone. We have also included the calculation of those images in the testing samples. So all in all, we have 1,400 images utilized for the entire process. And this is the CNN architecture of our study. So we have, again, input images are the herbal plants, capture images for the 10 classes. And we have utilized this configuration 64, three convolution layers. We have 64, 64, and 128 respectively. And the feed forward algorithm, which is responsible for um, mapping out the extracted features from the convolution layers to the corresponding classes. And for the mapping of the herbal plants, so what we have utilized here are the coordinates that we have gathered, and we have utilized QGIS to map it out in the web for us to be able to see the location of these herbal plants um, accordingly. Then this is the results and findings of our study. So the model was developed generated using a total of 800 training samples and 100 validation samples. And based on the training and validation, we have achieved an accuracy rate of 99.2% for the training and 84.3% for the validation. So these illustrates a, uh, a good behavior for our model, wherein for the training, for example, it has able to achieve like 99.2%. So it's quite high, that it we can say that the model is learning from the images that we have loaded. And for validation, so it's quite low, maybe because we have only utilized 10 images for the validation. So that is subjected for the improvement of our project of our study. And this is the confusion matrix using the testing samples. As observed, it is notable that there is a high frequency of predictions along the diagonal line, diagonal cells. So indicating that the model is doing well in categorizing or in classifying the samples, and higher values in these cells, so the better the model is at the making correct, meaning the model is making correct predictions for those particular classes, given the testing data samples that we have loaded for this model to classify. And this table shows the result of the various performance measures that we have conducted to know the performance further of the model. And it can be seen in the table, like say for example for Lagundi or the Vitex Negondo achieved the highest performance with both the precision and the recall rates of 96%. So this indicates that the model is highly effective at identifying Lagundi, supported by the specificity of 98.66%, which demonstrates its ability to minimize misclassifications of this species. And then, or this herbal plant. In contrast, the tuba-tuba or the Jatropha Corcus L. So it's exhibited the lowest performance matrix with a precision of 78.57% and a recall of 88%. So it suggests that the model can identify substantial instances of tuba-tuba, but however, it um, struggles to recognize other instances of this herbal plant. But the overall accuracy of this model achieved 85.2% with a Cohen kappa of 0.833, which is indicating that the model can recognize images and it can specify and classify accordingly the different unobserved samples to each of the class accordingly. And this is the sample interface of the mobile app. So this is a sample figure showing you that the images um, that you need to upload an image, and once uploaded, it will be recognizing that image according to its type, and it will also suggest the purpose, or I mean, the the different applications or remedies that we can do using this herbal plant. And if you want to see where can we find this particular herbal plant on the map, so we can click somewhere in the app, and then it will be loading a map showing some nodes here where we can find this herbal plant across the area. And so for the conclusion, the developed model for classifying herbal plants demonstrates a good performance using a data set of 800 training samples and 100 validation samples across 10 classes. It achieved a peak, I mean, sorry for that miss clerical error, that's 99.2% for the training and a validation accuracy of 84%, and also an overall accuracy rate of 85.2%. So additionally, the integration of the GIS allows the visualization of the geographical locations of these herbal plants, which can enhance further the models or the applications practical usage for the conservation effort of these plants. And for the recommendation, um, the data set, of course, can be expanded for the models to achieve a higher accuracy rate, and we can also expand other types of herbal plants to be included in the training and generation of the model so that it can cover a wider scope of herbal plants available in the area. I think that would be all about my presentation. Thank you so much for your attention, and um, would be appreciate your comments and your questions about this study will be greatly appreciated. Thank you so much.
Thank you. Very interesting question, please, Artem.
Thank you. Thank you for your report. It's really interesting. And
Thank you.
if it's possible, a few questions. The first one, is it the prototype or some concept? or it's a really working system with a mobile application and the data center that perform the running of these elements of artificial intelligence for recognition of the plants. So is it the prototype or it's a really working system?
For this particular study, it's still on the phase one of our development. Um, and what is really the intention of this is for us to be able to create a model out of machine learning for identifying herbal plants. And we intend to utilize and to model this result for us to go further with this study. We are planning to apply citizen science, wherein it's a way of gathering more data from the society or from the community,
Okay. So
so that we can train
this
further
is
the model to improve its accuracy.
sorry. This was only the first question to clarify. So this is the prototype yet, right? And if so, the second question uh, uh, is the plans that you are used for training of neural networks are unique for this region. I mean that they are located only here, right? Uh,
Yeah, these herbal plants are located in the Philippines, and some of it are also unique within the province.
so it means that you really can associate the exact or some plant with the location of it, right?
Sorry,
Uh,
pardon, sir.
I mean that you can really associate the location of some plant with the image, right? And based on that, you are performing the training of the neural network.
Um, you mean we can associate the location of these plants?
Yes.
Yeah. So once the plant is classified, we can associate with the location of the classified plants, and we can view it in the map, sir.
Okay. And the final question. Is there some really similar plants that can be mistaken, recognized as another plants? Because in your graph that you show, there was intensity up to 42, 46%.
Yes, sir. There are some misclassifications. Example, the tuba-tuba, it is misclassified with some other plants due to the similarity of the form and color. That's making the model like confused whether what's really the classification of this, and that's why our next step is to really conduct a citizen science for to open new opportunity for gathering more data, and maybe hopefully we can increase the accuracy rate of the model, sir.
It would be interesting to see. Thank you.
Yeah. Thank you so much for your question, sir.